The second part of this table that we want to fill out is reference angles. So the reference angles, notice we'll have reference angles in degrees, and then we'll also have reference angle in radians. So let's go ahead and take a look at what reference angles are. A reference angle is an angle in standard position. A reference angle of an angle in standard position is the angle formed by the terminal ray and the closest part of the x-axis. So that's the definition, and then just to note, the angles measure will always be between 0 and 90 degrees inclusively, which means it can be 0 degrees, or it could be 90 degrees, or somewhere in between there. So just taking a look at a couple examples here. If we had a angle in standard position that ended in the first quadrant. So there's an angle in standard position. Terminal ray, well, the closest part of the x-axis is the one on the right side of the x-axis. And so a reference angle in the first quadrant will just be itself. So let's go fill those out. A reference angle in the first quadrant will be itself. So first quadrant, including 0 and 90, which really aren't in the first quadrant, they form the first quadrant, but these are just going to be the same as the actual angle, because the angle formed between the terminal ray and the closest part of the x-axis is simply that angle. And we can do the same thing with radians. Now, what about looking at the second quadrant? So I'm going to put another x and y axis here. There's our angle in standard position coming in the second quadrant. Well, what's the closest part of the x-axis here? Well, it's over the left part of our x-axis. So if we were thinking about degrees, that's all the way to there is 180. 180 degrees to there. Well, we would want to subtract our actual angle to get our reference angle, which I'll mark here in green. So our reference angle in this case would be the green one. And in the second quadrant, it's going to be 180 minus the angle. And that will give us our reference angle when dealing with degrees. And so we can do 180 minus 120. That's 60. 180 minus 135 is 45. 180 minus 150 is 30. And 180 minus 80 is 0. Well, what about radians? Radians here do match up. They match up with the degrees. So we could do this one of two ways. We could just look at our degrees and realize that they're the same as in the first quadrant. Or we could look at the angles again. We're just going to compare here because it's easier in this case to look at the degrees. So if we converted 60 degrees to radians, we can look up to above here, and it's going to be pi over 3. And then 45 degrees converted to radians is pi over 4. And 30 degrees to radians is pi over 6, and 0 is 0. So that's one way to look at it, and it's helpful because we can quickly fill out this chart. So we'll convert find our reference angle in degrees, and then just change those to radians. All right, 210. So now we're in the third quadrant. So in the third quadrant, standard position, somewhere in here, how are we going to find the reference angle? Well, the reference angle will be this green one. Well, in order to find that green angle, we're going to take 180 and we're going to subtract that from our actual angle. So we're going to take our angle, which is the blue, we will subtract 180, and that will give us the reference angle. So that's in the third quadrant. And you don't have to memorize those things. We're just looking at them to help us figure them out. So For this third quadrant, 210 minus 180 is 30. 225 minus 110 is 45. And 240, I think I said that wrong. 225 minus 180 is 45. And 240 minus 180 is 60. 270 minus 180 is 90. And again, we can convert these. A 30-degree angle is pi over 6 radians. 45 is pi over 4. 60 is pi over 3. And 90 is pi over 2. And then for our fourth quadrant, our reference, here's the beginning ray, and then the terminal ray is going to be in the fourth quadrant. Well, the closest part of the x-axis is actually the positive part again of the x-axis again. So what we're going to do is we're going to take the full 360, so the full 360 degrees, and we're going to subtract our actual angle here. So minus this angle will give us our reference angle. So this is going to be 360 minus the angle. So we can come over and finish our chart. 360 minus 30 is 60 degrees. 360 minus 15 is 45 degrees. 360 minus 330 is 30 degrees. And 0 degrees. And again, we can convert these to radians. 60 degrees is pi over 3. 45 is pi over 4. 30 is pi over 6. And 0 degrees is 0 radians. So now we have all of those radian measures, reference angle measures. And there are some nice things we can recognize here, reference angles when working with radians. Notice, if you look at this column compared to our original, as long as these are all reduced in this column here, the reference angle is simply the same denominator, pi over 6. So just looking individually at 2 pi over 3, looking over at its reference angle, it's just pi over 3. Let's pick another one. 5 pi over 4, pi over 4. So it's just pi over the denominator, and that's as long as it's reduced. So if an angle in radians is reduced, it still has the pi in it, then it's just going to be the pi over whatever the denominator is. Another nice thing to recognize here is some quick conversions. So degrees to radians. Sometimes we're not as familiar with radians, so there's some quick things. If you see it's pi over 6, something over 6, that goes with a 30-degree angle. Pi over 4 relates to a 45-degree angle. Pi over 3 goes with a 60-degree angle, and pi over 2 goes with a 90-degree angle. We don't want an arrow there. So those are some quick conversions. If you're in radians, you should know what the reference angle in degrees is very quickly. So that's how we find the reference angles. Reference angles are going to be used to help us fill out these last 3 columns pretty shortly.